So after the series combination of capacitors, what you have now is the parallel combination of capacitors. So second type of combination, this is parallel combination. Parallel combination. The two ends are to be joined together and connected together. Then here, this is how it will look like. Capacitor C1 is here, C2 will be here, C2 will be here, then C3 will be here, and these two ends will be connected common to a battery of potential difference V, a plus minus. This is the potential V. Then this charge Q will come through this end, charge Q. For the charge Q to flow, you have three different paths now. One can pass through C1, one can pass through C2, one can pass through C3. So the charge coming through this one is Q1, C2 na Q2, C3 na Q3. Then when you add up this Q1, Q2 and Q3, the sum will be equal to the total charge Q. This is obvious by conservation of charge. So, like what you have done in the previous derivation, by definition of capacitance, this C1 will be how much then? Q1 by V. Why we are using Q1? Because charge Q1 is passing through C1. Potential V will remain the same because in parallel combination, as you know, the potential is always constant in parallel combination. That's why it should be only V. Then C2 will be how much? Q2 by V. Similarly, C3 will be how much? Q3 by V. Then equivalent capacitance Cp will be how much? Total charge by total potential. Okay, so what is Cp? Equivalent capacitance of parallel combination. Then today na ngasay minus Q1 putuan holen kay tani. Q1 will be C1V, Q2 will be C2V, Q3 will be C3V. How about Q Cp into V? Then as I told you, by conservation of charge, this total charge Q should be equal to Q1 plus Q2 plus Q3, and the Cp was equal to total charge by total potential V. Let us observe here. This total charge coming through this junction Q should be equal to the sum of these three charges, Q1, Q2 and Q3. Then if you find Q from here, sidagi ng Q puto, ito kasi hapsulo kay tani Cp into V tani. Q1 sidagi puto kay tani C1 into V tani. The Q2 this sidagi puto C2 into V tani. Sidagi Q3 puto di C3 into V. Asidadi kali common no re koi si case sidadi V is common. This in there going to so your ultimate relation is Cp equal to C1 plus C2 plus C3. So this is the equivalent capacitance of three capacitors which are connected in parallel. Aduna, in the same way as we have done in the previous derivation, let us take up special conditions. Then when you have only two capacitors, case number one, when you have only two capacitors, case number one, this Cp will be how much? You will simply add up C1 and C2. When you have only two capacitors, you will take only up to the second term. Then when you have n number of capacitors. This will be how much? C1 plus C2 plus C3 up to kadai potential Cn potential, then C kamai ibe summation Ci I goes from 1 to n. This is in terms of summation. Then C the decay Roman number third condition the decay over. If aside minus C1, C2, C3 up to Cn power C ga say, then the C single loy mana C on the try C Maria Cincinnati 4C n times Cincinnati Cp will be n times of C. Okay, so you have three formula now which can be used to solve some problems. Then what I want you to know is just the brief summary of both the two derivations. That means series combination and parallel combination. So in series, 1 by Cs was equal to 1 by C1 plus 1 by C2 plus 1 by C3. Alright, then in parallel combination, Cp is equal to simply the sum of the three capacitance, C1, C2 and C3. So by using these two formula, you can solve so many problems. Okay, when you have three capacitors, you will add up to C3. When you have two, you will add up to here on. Okay, this is all about the combination of capacitors.